Welcome. So periodically, besides teaching you calculus, I'll be reviewing some skills from Algebra 2 and pre-calculus that will be important, very important as you learn calculus, right? And the first lesson is factoring. Right? So we're going to do all kinds of factoring because if you can't factor, you're not going to be able to solve some of the equations that we're going to be dealing with as we progress through calculus. So let's look at the first one. We have 64x cubed minus 27, and then we have 64x cubed plus 27. Now, you can use, these are patterns. We have a difference of cubes and a sum of cubes. Right? And when you have a difference of cubes or a sum of cubes, right, there's a handy-dandy way that you can factor. Just like there's a handy-dandy way to factor a difference of squares. There's not a handy-dandy way at all to factor a sum of squares. But there is one for a sum of cubes. So for both of these, U and V are perfect cubes. By the way, I'll be posting, besides of course, you're watching the video, I'm going to post the notes as well on Schoology. All right, so, and if you can take notes if you want, you can print these out if you want, you can refer to them as you're doing problems, whatever is best for you. You might want to print them out, I don't know. So, for U and V are perfect cubes. First of all, we have a difference of cubes, right? So U minus V, if you have a difference of cubes, that is going to be equal to the cube root of U minus the cube root of V times the cube root of U squared plus the cube root of U times the cube root of V plus the cube root of V squared. So this thing here is a U. It didn't really want to cooperate. Make it kind of more rounded. There. Hopefully that looks like a U. All right, so you can use this pattern to factor any difference of cubes. All right, so now I'm going to plug those into the formula there. Okay, so 64x cubed minus 27 is equal to, so U is this part's the U, this part's the V. All right, so it's going to be the cube root of, oops, forgot my parentheses, cube root of 64x cubed minus the cube root of 27 times the cube root of, just plug in the U again, 64x cubed, but that's going to be squared. You know, one thing I should have done is maybe orient the board. I think it's just a glitch in the board. I don't think it's an orientation problem there. I think as I go lower though, I'll get rid of that waviness that I'm seeing right now. Plus the cube root of 64x cubed times the cube root of 27 plus the cube root of 27 squared. All right, now we're just going to simplify it, and voila, it's factored. Cube root of 64 is 4. Cube root of x cubed is x. Minus cube root of 27 is 3. Of course, the cube root of 64x cubed is 4x. But now we're going to square that. Actually, I'll write 4x squared. I don't want to lose anybody. 4x all squared, right? Because the cube root of 64x cubed is 4x, and we're going to square that. Plus, the cube root of 64x is 4x. The cube root of 27 is 3, plus the cube root of 27 is 3, and then we're going to square it. All right, so now we'll just simplify this part out and we're done. All right, so 4x minus 3, 4x squared is 16x squared, plus 4x times 3 is 12x, and 3 squared is 9. Now, do you have to write out every single step? No, not if you can do it in your head. All right? You might be able to keep in your head, okay, cube root of 64x cubed, that's going to be 4x, times the cube root of 27 is 3. 4x times 3 is 12x. Right? You only need to write down as much as you need to write down, right, to be able to factor. But here I wrote everything down so that you could see all of the steps. All right? And so, just make sure you understand those, right? Because you'll have some problems like that in BOWork this week. All right, so now I'm going to try the next one, which is the same thing, but it is a sum, right? So if I have a sum of cubes, so if I have, and again, for both of these, u and v are perfect cubes. If I have u plus v, and they're both perfect cubes, right, this is going to be the cube root of u plus the cube root of v. Actually, it's going to be very, very similar. The only thing that's going to change is the signs, right? So you already see that in the first one we had a minus. This time we have a plus, right? And then there's only one negative in the whole thing. You just got to remember the second term is negative. And then otherwise the middle terms wouldn't drop out and you wouldn't just have a sum of cubes. Then we have the cube root of u squared minus, after I just said it was negative, minus the cube root of u times the cube root of v plus the cube root of v squared. So let's just kind of compare the formulas. And the first one, the very first, there's one negative. Everything else is a plus. Right? That one negative knocks out everything in the middle, and it leaves the second term negative. When we have the sum of cubes, right, the first part is a plus, and that middle term is a negative. It's the only negative. Right? It's one negative in each one of these. And that one negative is going to knock out the middle part, but it's going to leave the last term a positive. Right? But you can just remember that. The pattern, actually you just have to remember one thing. Just remember where the negative is. In a difference of cubes, it's that first expression, the second term is negative. In the sum of cubes, it's the second expression and the middle term is negative. Right? So we're going to factor 64x cubed plus 27. So that's going to be equal to the cube root of 64x cubed, cube root of 27, times the cube root of 64x cubed, all squared. Oops, I need another parentheses here. Minus the cube root of 64x cubed. I'm going to make that long enough. Times the cube root of 27, the cube root of u times cube root of v, plus the cube root of 27, okay, if you squeeze it in there, squared, and a parentheses. Oh, almost. Let me see if I move it over just a tad. We're losing the end of this equation here. And then I can write that maybe a tad neater on the end there. There we go. All right, now we'll just simplify. And we will have factored a sum of cubes. All right, so again, cube root of 64x cubed is going to be 4x plus the cube root of 27 is 3 times the cube root of 64x cubed is 4x, and we're going to square that whole thing, minus cube root of 64x cubed is going to be, 4x times the cube root of 27, which is 3, plus the cube root of 27 squared, which is going to be cube root of 27 is 3, so 3 squared. And then we'll simplify. Equals 4x plus 3 times 16x squared minus 12x plus 9. So you see you get the same thing with the difference of cubes and the sum of cubes, except for the negatives in a different location. Right? That's all there is to factoring difference of cubes and sum of cubes. And once you get the pattern down, right, it's really easy to do these. This is, I chose, by the way, one of the hardest ones I could do. If I chose something a little simpler like x, let's just say I took x cubed plus 27. Let's take the 64 off of it. So if we had x cubed minus 27, right, then it would just be x minus 3 times x squared plus 3x plus 9, right? Because it would just be the x squared, excuse me, it would be the, so the first so in other words, we wouldn't have the coefficient in front, right? So it would just be the cube root of x squared, which is just x squared. And the cube root of x times the cube root of 27 is 3x, and the cube root of 27 would be 3. Right? So without that coefficient in front of the x cubed, then it gets pretty easy. Right? And if it was x cubed plus 27, then that would just be x plus 3 times x squared minus 3x plus 9. All there is to that. All right, we did the other one on the previous page. Let's do the next one. This is just factor by grouping, all right? First two are a group. Second two are a group. Hopefully you remember this from Algebra 2. All right, plot a greatest common factor. Greatest common factor for x cubed and 3x squared would be x squared. X cubed divided by x squared is x. 3x squared divided by x squared would be 3, so we'll have x minus 3. Greatest common factor for 3x, whoa, is this, I have a problem here. Greatest common factor is 1 and it doesn't match. Well, let's try to, I assume I put this here to factor. Let's try changing the order of things. Let's make that x cubed minus 1 minus 3x squared plus 3x. Let's try that. All right. Great. So first two are a group. X cubed minus 1. This has to be a plus. And the second two are a group. Negative 3x squared plus 3x. If this doesn't work, then I don't know what else to do. All right, so here we can factor this. This is a difference of cubes. We're going to use that pattern we learned. I, by the way, did not solve these out ahead of time. So I'm going to be doing them along with you. All right, and then here we just pull out a greatest common factor, so no biggie. All right, so if you pull out the greatest common factor here, we could pull out a 3. Actually, let's pull out a negative 3. Let's make that x squared positive. All right, if we pull out a negative 3, that's going to be, oh, excuse me, negative 3x. If we pull out a negative 3x, that's going to be x minus 1. All right, so now let's factor the difference of cubes. All right, so that's going to be cube root of x cubed is x. Cube root of 1 is 1. So it's going to be x minus 1. Whoo, we got something we could factor out, which you're going to see in a moment. All right, and then it's going to be the cube root of x cubed squared, so that's going to be x squared, times the cube root of x cubed times the cube root of 1. So, and this is going to be a plus. It's going to be all pluses now. So that's just going to be plus x. And then it's going to be a plus. The cube root of 1 is 1. Now we have a greatest common factor. Right? We've got an x minus 1 here and an x minus 1 here. So we can do factor by grouping here. We can pull out the x minus 1. If we factor an x minus 1 out of the first term, we're going to be left with x squared plus x plus 1. Oops. If we factor out an x minus 1 from the second, because we're factoring out an x minus 1 from both, right, we're going to be left with a minus 3x. Right? So I can drop this set of one of those parentheses in there, right? Because I'm just going to combine like terms. Right? I can drop the parentheses. Right? So we factored an x minus 1 out of x squared plus x plus 1. We factored an x minus 1 out of, let me see if I said it. Let me say that one more time. We factored an x minus 1 out of x minus 1 times x squared plus x plus 1. We factored an x minus 1 out of negative 3 times x minus 1. And so we're left with x minus 1 times the other two factors. Now, we can combine like terms. So now this is x minus 1 times x squared plus x plus 1 minus 3x. Let's combine those two like terms. So we have x minus 1 times x squared minus 2x plus 1. And this can be factored. Multiplies to give us 1, adds to give us negative 2. X minus 1 times, this is x minus 1 times x minus 1. Am I not? Because that would give us x squared minus x plus another negative x plus 1. Yep. So, all factored. Isn't that bizarre? It's x minus 1 cubed. This was x minus 1 cubed. Strange. I'm just double checking my work here. No, I don't see any mistakes. If you see a mistake, let me know. All right, and then let's do the next one. Yeah, that would make sense, actually, because that'd be x minus 1 times x minus 1 times x minus 1, right? So it's not a difference of cubes, right? It's the same factor cubed. Very interesting, that. And actually, now that I'm thinking about it, getting my brain back into math mode after a very long summer, if we remember Pascal's triangle, right? If we have something raised to a power, to the third power, right? It's going to be the first one cubed, right? And then it's going to go, this would be, actually, let's just go over that. So if I have x minus 1 cubed, I'm going to have x cubed. And then we have to remember the signs, but it would be nicer if it would be x plus 1. No, you know what? I'll go over Pascal's triangle at a later date. But the coefficients here, the 1, 3, 3, 1, come off of Pascal's triangle. Those negatives occur. Notice that we're alternating negatives. We're alternating negatives there because our binomial is negative. But we did do the factoring, right? And if we were to multiply that out, once we get to multiplying things out, I'll kind of go over that. but we're good there. I will go over Pascal's triangle, though, to help you on multiplying, raising a binomial to a power. But I'll keep this one to just factoring. I'm at long enough as it is. All right, let's try factor by grouping without having to do fancy schmancy things like switching terms around and taking differences of cubes. All right, so x cubed, should have given myself another page, huh? X cubed plus 6x squared. First to our group, plus 12x plus 8. Second to our group. Greatest common factor is the x squared. Right? Divide both of those by x squared. We have x plus 6. Nope. Because greatest common factor is the 4, and that is not going to, it is not going to give us a repeating binomial. Nope. Let's try switching the terms around. And guess what? This one is just like the other one. I can see it. And I am not going to have enough space. So I'm going to clone my page. Oops. Whoa, that was really off. All right. Well, sorry. Here, I'll come up to the computer and clone it. Oh, I did. I did clone it. Okay. So we're going to get rid of this. So if you don't get a repeating binomial when you're trying to do factor by grouping, try switching the terms around. And I can see x cubed plus 8, if I put those, I'll just rewrite it first. X cubed plus 8 plus 6x squared plus 12x. All right, so first to our group, x cubed plus 8. Oh, look at that. A sum of cubes plus 6x squared plus 12x. Factor out the, we're going to factor using the pattern for a sum of cubes. So this would be cube root of x cubed. So it's going to be x plus cube root of 8 would be 2. So x plus 2 times x squared, and then the cube root of, and it's going to be minus, cube root of x times the cube root of 8, so that's going to be minus 2x, and then plus the cube root of 8 squared, so 2 squared, or 4. There we go. Plus, and we could factor a 6x out, and we'd be left with x plus 2. So we have a repeating x plus 2. We can factor that out. We're left with x squared minus 2x plus 4 plus the 6x. I'm just going to combine them right away. Right? There, we're just if we factor out an x plus 2, we're going to be left with, I use a different color here, this plus this. All right, so now let's combine like terms. I wonder if we can factor this one. X plus 2 times x squared minus, plus 4x plus 4. Yep. All right, x plus 2 times x plus 2. Perfect square. Oh, look at this one. X, surprise, surprise, surprise. Which is just x plus 2 cubed. How about that? Right, because 2x plus 2x would be 4x, and then 2 times 2 is 4. So 2 very similar problems. All right, so we do have just a straight, right here, straight factor by grouping. But let's look at number 4. I don't really like those exponents. I got to the 4th power. Oh no, you know. But don't worry. Let w equal x squared. We can use substitution. So if you don't really like the exponents you have, and one is just the other exponent squared, right, just use another variable. We usually just say w, because w wasn't doing anything anyway. And let that equal x squared, then w squared equals x squared squared. And when you raise a power to a power, you multiply exponents. So w squared equals x to the fourth. So now we have w squared plus 11w minus 80. And now we can just factor. Right? So we need two numbers that multiply to give us negative 80, add to give us 11. Right? Because when we're factoring, right, multiplies to give you a times c, adds to give you b. Right? So a is 1, c is negative 80, and b is 11. Let's see, factors of 80. Well, it's not 8 and 10. They're not 11 apart. Right? And one's going to be positive and one's going to be negative, right, because they multiply to give you a negative number. 20 and 4, no. 16 and 5, there we go. Right? And the 5 got to be the negative one because they have to add to be 11. So we have w squared minus 5w plus 11w minus 80. And now we can just do factor by grouping, right? We've split. Factor by grouping works when we have a quadratic by rewriting it so we have four terms. Right? You should, hopefully, we spent a lot of time on this in Algebra 2. Hopefully you remember from Algebra 2. First two become a group, second two become a group. Always when you do factor by grouping, make sure they're combined with a plus. Otherwise, you'll accidentally be distributing a negative that you didn't mean to. All right, so pull out a w here. We get w minus 5. Pull out, oops, why did I write 11? I'm looking at the 11 right next to it. Sorry, that should be a 16, right? Negative 5 plus 16. Pull out a 16. We have w minus 5. And then we factor out the w minus 5, right? Just like we did in some other problems, because that is a repeating factor. Right? And we're left with w plus 16. But we put the w in. W wasn't there before, so we do have to factor back out again. So the w is an x squared, right? So x squared minus 5 times x squared plus 16. You couldn't possibly do anything with x squared plus 16. You can't factor a sum of squares. You can factor this. Really, you could just leave it as x squared minus 5. And if you were solving, right, then you'd have x squared minus 5 equals 0. And, add 5 to both sides and take a square root of both sides, right? If you really wanted to factor this, but you don't have to, I'm fine when you get to that point because 5 is not a perfect square. You could write x minus the square root of 5, x plus the square root of 5, right? But nothing you can do with the x squared. I'll put or plus 16. All right, that one's done. I really should put less problems on the page because I write really big. But that's okay, you have to be able to see it. The first one let's try factor by grouping, and I always try first just the way they are. And if that doesn't work, try switching the terms around. Especially if you've got perfect cubes. We have no perfect cubes here. We don't even have squares here. All right, so first two are a group, AC plus CD. Make sure this is a plus. All right, the negative goes with the AB. Negative AB minus BD. All right, greatest common factor is a C. If I factor out a C, I've got A plus D. Greatest common factor here, better pull the negative out, is a negative B. And we've got A plus B, right? Because negative BD divided, negative AB divided by negative B would be A. Negative BD divided by negative B would be D. All right, and we can factor out the A plus D, the repeating factor, and we're left with C minus B. So there were numbers in there that work the exact same way. All right, so that's the pattern for factor by grouping. All right, you plot a greatest common factor, and if you do that and the binomials match, that's one factor. What you pulled out is the other factor. All right, here, all right, I don't like that, the ordering here, because I've got a squared, and a term with an x and a y. All right, so let's reorder that to 2x squared minus 20xy plus 50y squared. All right, we'll reorder that. Well, right off the bat, we could pull out the 2. We should probably do that. X squared minus 10xy plus 25y squared. Well, if you don't like the, so if you kind of notice the pattern here, this is a perfect square, right? We've got x, a perfect square. We end with a perfect square. Right? And in the middle, we've got the square root of 25 times 2. We've got the square root of the x, and we've got the square root of the y. So if you've got a perfect square, I'll use x minus since minus is in here. So let's I'm going to use different letters. Let's use u and v. U minus v all squared. Right, you've got, and it'd be the same thing if it was u plus v, except the negative 10xy would be a plus 10xy. But if you have u minus v all squared, it's going to be u squared. Over here, I'm going to have plus v squared. And in the middle, I'm going to have minus 2uv. Right, so the u is the x, the v is the, we've got 25y squared, the v is the 5y. All right, and if you take x, if you take 2 times x times 5y, you get 10xy. If this had been a u plus v squared, it would have been then u squared plus 2uv plus v squared, just the sign. So this is going to be 2 times x minus 5y squared. That's all there is to that one. If you have questions, let me know. All right? But it's just we clearly have the product of a perfect square. So we have something times itself to get that pattern. Right? Oh, I'm a little longer than I thought. So I'm going to do 1. I'm going to have to make this 2 videos. 2. And then, you know what? I'm going to split this up so my videos aren't so long. And actually, I am going to stop it right here, and then I'll pick up in the next video. All right? Thanks for watching. Bye for now.